Gather around, llamas. It's time for another video. Today we'll explore the infinite and wondersome fractals. What if you wanted to measure the coastline of the United States? It's easy, right? Just find a measuring point of reference, like a segment of 120 miles or 193 kilometers. In relation to the map on the right, it would be this long. Now we use this 120 mile long segment to measure the coastline. It would look something like this. That looks pretty accurate. Then we count the segments and there are 91. So now we multiply the number of segments by 120 to find out what the coastline is in miles. So the coastline of the US is 10,920 miles or 17,575 kilometers. What if we wanted to use bigger segments? Well, we could do just that, except this time use segments of 350 miles or 563 kilometers. That would be this long in relationship to the map. After using that as a measuring stick, the map would look like this and would have 28 segments. Then we multiply that by 350 to get our coastline in miles. That would equate to about 9,800 miles or 15,770 kilometers. And that's a 9% decrease from when we used our 120-mile measuring stick. However, according to NOAA, the coastline of the United States is 95,471 miles, or 153,646 kilometers. What just happened? All three ways of measuring the same thing were totally viable strategies. This is what's known as the Coastline Paradox. Let's look at the 120-mile segment map next to the 350-mile segment map. Washington, D.C. on the left map is pretty precise, yet Washington, D.C. on the right map couldn't have been as precise because those bumps aren't something that a larger measuring stick can measure. Same thing with Florida and Alaska. That means that a lot of coastline was cut off in measuring with 350-mile segments. Now let's look at the 120-mile measurement map next to NOAA's measurement map. The Alaska tip is nowhere near as precise as NOAA's measurements. Alaska's southern area of islands wasn't measured as precisely. Washington, D.C. is a lot less intricate, and the Great Lakes weren't included in the measurements, whereas NOAA did include them. So basically, the smaller the measuring stick, the larger the coastline you will measure. You can go as far as to measure the US in millimeters, or 10 to the power of negative 10 meters, or even 0.8768 of a femtometer, and if you keep decreasing the length of your measuring stick, the United States of America could theoretically have infinite coastline. Come on over to United States. We got beaches galore. The Coastline Paradox is an example of a fractal, which is a figure with finite area yet infinite perimeter. The most well-known fractal is this one on the left, which is one of Mandelbrot's fractals. All you have to do is graph the mathematical equation z sub n plus 1 equals z sub n to the power of 2 plus c, and you will have your very own fractal. That, or you can just look up fractal zoom on your search engine and several mind-blowing videos will pop up. Back on track, USA's coastline is equal to the number of digits on pi, the number of recurring patterns on the Mandelbrot fractal, and the amount of numbers that exist. All of these are infinite numbers. What is the surface area of Earth? Well, that's easy. We just use the formula we learned in 10th grade geometry, 4 pi r. It is a formula to find the surface area of a sphere. Earth's radius is 3,960 miles, or 6,373 kilometers, give or take a few based on elevation. Plugging that into the formula, you get 4 pi times 3,960, or 15,840 pi. Calculating that gives us about 49,763 square miles, or 80,085 square kilometers. What if you had another planet with the same radius and volume of Earth, just it's the smoothest sphere ever possible to exist? They both have a surface area of 49,763 square miles. Or do they? Earth is not exactly a sphere. It's very close, but not exactly. Earth has bumps and divots all over it. This means you can apply the same concept as used with the Coastline Paradox. If you use a longer measuring stick to measure the surface area of, say, a pebble on the ground, then you won't get as accurate of a measurement as of a smaller measuring stick. And the smaller the measuring stick, the greater the surface area. Let's say that you use measurements of square femtometers, which for your information is an extremely small unit of measurement. This means that Earth's surface area will be a number too big for even the most complicated calculator ever created to be able to comprehend, whereas a smooth planet would have a surface area of the 49,763 square miles that we calculated earlier. Let's look at the universe. This is the observable universe. We can't see farther because light from beyond that hasn't yet reached Earth. Here's our neighboring galaxies. Now let's zoom in. Here's our galaxy. Here's our solar system. Earth, a mountain range, a few trees, some leaves, some plant cells, a plant cell nucleus, the tree's DNA, a protein molecule, a carbon atom's nucleus, and here are the 3 quarks inside one of the carbon atom neutrons. Everything is a fractal. You can zoom in more and more, and there is always a smaller thing to make it up. I hope you llamas enjoyed today's episode on fractals. Like if you liked it, subscribe if that's what you feel like doing. I hope you have a Llamaful day.